Hi all, I am Dr. T. Lokeshwari, working as an assistant professor in the Department of Computer Application, PG, Dr. SNS Rajlakshmi College of Arts and Science. Today, I am going to discuss about encoding of conventional code. Introduction. First, we should know why we are going to study that particular topic. In my previous video, I have discussed about what do you mean by communication system. So what are all the advantage and disadvantage, everything we have discussed. So the main theme of studying this conventional coding means when you send a data over a communication system, the data might be affected. That means noise may occur. To reduce this error, we are using some special coding methods. That is nothing but one of the such method, that is conventional coding. How we are going to minimize that error in a sense? We are going to add some extra bit to the message to help to detect and correct error at the receiver end. So when we are having that original data, we are adding some extra bit over that. So it is easy to find out, detect and correct the error at the receiver side. Where we are using these conventional codes? It is basically used in wireless communication, satellite communication, and digital broadcasting. So the basic purpose of using this conventional code is it's a type of error correcting code. It is used in information and coding theory, particularly in digital communication system. So what you will write about definition? In order to protect our data, by using a system of shift register and logic circuit. Here we are going to give only one input bit at a stretch and it will produce two output bit based on the current and the past input bit. So in order to find and fix the error during the data transmission. This shows the simple diagram of a conventional encoder. See, when we are giving an input, that input, it will be a one single bit we are going to give. It's not a block. Again, I am repeating, it will not be a block. It is a single stream. So here G1, G2, that is nothing but your generator polynomials. Based on your input, the XOR gate will produce some data. That data will be the output 1 and output 2. So one input you are giving and you are getting two outputs. The basic point here, you should remember few things based on the diagram. It is a type of error correcting code that you should keep it in your mind. Already in that definition itself we discussed about, it adds some redundancy to the message in order to protect the transmission error. Second, it will work on bit stream, not block. Yes, there, what did I say? Here we are going to make only one single stream, that means one input we are going to give. Either it will be a zeros or ones. So when we are giving that particular data, the codes will process continuously. Another one, here we are using shift register. In this shift register, because basically it is done in encoding. So here we are using two adder, that means XOR gates. So when we are giving that input, it will go for generator polynomial, then it will XOR that and it will produce the output. That is what we discussed. So the output bit depends on the current and the previous input bit. The next important thing we should keep it in your mind. Here we are using three parameters, N, K and M. N is nothing but a number of input bit. Already I said here we are going to give one input, in the sense one input. Then N equal to number of output bit. The output bit will be 2. M equal to constraint length. That means the number of memory element what we are using in the shift register. For example, when we are using 2, 1, 3 in the sense, here one input bit gives two output bit and the memory length will be 3. That is the scenario they have given here. The next important one we should remember as code rate. That means it describes the level of redundancy. How much we are using that data repeatedly. For example, we are adding some extra bit, right? So that how much, that in order to find out the error correction. Generator polynomial. I said when you are giving that input G1, G2, two generator polynomials we are going to use as an indicating of how input bits are combined. For example, here if you are using G1 in the sense the output will be 111. If you are using Z2 in the sense the output will be 101. The another important thing is trellis diagram. In order to visualize the state transmission, how it will be moving from one to another, that will be used in the help of trellis diagram. So in this algorithm, we are using this Viterbi. That means how the decoding will be happening with the help of data. So today we have discussed about convolutional code, one of the way to error correcting that, and what are all the things we should remember in this. So this session will be useful for you. The next class we will discuss about another one. Thank you so much.